Intelligent battery management solutions improve system reliability, safety, and efficiency while providing accurate determination of battery cell states, battery pack current control, and fault diagnosis. Qorvo's highly integrated PAC 22140 and PAC 25140 battery management solutions incorporate an ARM MCU, switching regulators for high power operation and individual cell balancing. They are fully programmable for battery applications from 10 to 20 series lithium-ion, lithium polymer, and lithium iron phosphate battery packs. They also provide cell monitoring and temperature management, short circuit protection, overcurrent charging and discharging protection, and low power hibernation. The PAC 22140 and PAC 25140 are similar, except the PAC 25140 has a more powerful CPU, additional memory, and a CAN peripheral. The first step in starting your battery management solution is ordering the PAC 22140 or PAC 25140 evaluation kit from Qorvo. The kit includes the battery management evaluation module, an isolated and serial interface board, and all pertinent cabling. All you need to add is a suitable SWD debugger. The kit comes with hardware application support and access to battery management algorithms for cell balancing, application examples, a software driver, bootloader, and other miscellaneous software tools to get you quickly started. Let's review the process on implementing an actual application. Using the Qorvo.com landing page for the PAC 22140 as an example, locate the individual software tools and reference documents in the Documents tab. On the Evaluations Tools tab, you can locate the user guide, schematics, layout files, supporting tools, software files, and drivers to enable your desired application. Out of the box, the firmware is not installed on the EVK. Therefore, you will need to install the firmware located on this Evaluations Tools tab. To power up the evaluation board, you first need to select the number of battery cells in your application, as shown in the user manual. This is done by applying a short at the proper terminal. For example, in this scenario, we are selecting a cell count of 10. Therefore, we apply a shunt wire on 10 of the connector pins. Or, if you desire a more permanent cell selection, attach a 0 ohm resistor on the underside of the evaluation module at the 10 connector pins. The easiest EVK application is using a power supply to emulate the battery pack and a DC load or power resistor functioning as a load. For this scenario, you'll need to connect the isolation and serial communication interface board and debugger to the respective terminals as shown in the user manual. After applying power to the module, the LED D4 will light up. Using your desired IDE, program the application into the battery management module. The first time you use the graphical user interface provided within the project, you will need to select the serial communication port. To do so, go to the Config drop-down menu on the GUI and select COM port config. Press the Detect button to obtain a list of available COM ports. Select the COM port to which the serial communication interface is connected. Press the Save button to enable the module serial communications. At this time, the graphical user interface will be reporting battery pack parameters such as state, stack voltage, and individual cell voltages. By selecting the Individuals tab, you can view the status, change settings, and data logging features. For additional information on how to use all the features in the battery management solution, please refer to the user guide included within the firmware project. For more tools, technical blogs, and ebooks, visit Qorvo's Design Hub. We're your partner for the toughest design challenges.